45-minute round of hardware. Perhaps let me open a few tabs to see if, yeah, save a little bit of time. So when ground is 0, comes not this cycle, but the next cycle. So let's build the base state machine where we do bump left, bump right, and walk left, walk right. Walk left is reset, so this is a asynchronous. Asynchronous reset is, I guess, the naming convention. So if I'm left and I bump left, go right, otherwise left, right, left, bump left. Okay. Okay. And then one could say like, so is really is really one cycle delay of not ground. If you look between ground and so if ground deasserts, then the not of this is 1, and then the same here. If 1, then next cycle it's the not of 1, which is 0. And if is asserted, then walk left and walk right are muted. So we just gate it off like so. And then I guess can reset to 0, and can then just be not ground, like so. Okay, let's fix this first, because I feel like I'm just gonna extend the state machine, so copying and pasting is good. I don't have a reset, so input is bump left. And obviously if I bump left, so this one, I say walk right. Okay, walk left, bump left. I see, so bumps are ignored when there's no ground, which makes sense. So if no ground, the state doesn't move. Okay. Ground reappears here and I bump left. But this bump left is ignored. So I guess bump left is ignored, not when the ground shows up. So even though the ground shows up, it doesn't take an effect until the next cycle. So bump left and I walk left, but it doesn't matter. So because ah is asserted, and then here we have bump left and walk left, and ah is not asserted, so then it's only when ah is 0. So actually, like this, I guess. Walking on ground, and we'll continue digging until it reaches the other side. So the lowest level is like bump, and then if you get bumped while you're digging, it doesn't matter. Also notice that once you start digging, then you don't walk left or right, you actually just focus on digging until until A asserts, and then when A asserts, any dig, I guess any bumps also is ignored. And then the state machine is preserved. Okay, there's still mismatches, which is annoying. So we start with walk right, and the ground goes down for us for a cycle, I guess. Yeah. And then again, so the bump is ignored if ground is 0, or if so as soon as ground is 0, the bump is ignored, and also bumps are ignored until one cycle after ground is asserted. So if ground is 0, it'll ignore a bump. And it keeps ignoring it until it'll so if I'm zero, this is ignored immediately on this cycle, and then so bump right is ignored, so then we keep going right. And then also here this illustrates bump left on bump left doesn't matter because this signal is low. Sorry, bump left and ground is going to the right normally, except this is asserted. So it has to be 1 and 0. Yeah. So this satisfies the spec up to the ground and the ah. But now we need to build a layer on top of that to say, hey, we start digging. In other words, dig sets digging, and not ground clears digging. And bumps are ignored, so, and not digging for both of these. So this original state machine is just the bump state machine. So this will ignore, this will kind of turn off the evolution of that state machine. And then after this point, we resume our ground and not ah situation to start listening to the bumps. And then okay, so this is the same as this condition where it must be ground and not ah for dig to not be ignored. So, so these are the conditions where we can actually dig, and then this dig enable sets the dig. And we clear the dig when there is no more ground. So if this goes to 0, we'll clear it. Can I have this and this at the same time? No, because these are polar opposites. So if this is 0, this is 1, and if this is 1, then this has to be 0. Am I missing something here? We have digging. We have start digging based on these qualifiers, so we ignore dig when we're falling. And yeah, we start digging on dig, and then we stop digging on this. and that's the interaction with digging and the ground. But what about digging and walk left, walk right? Then if we're digging, then bumps are ignored as well. I guess is there some kind of like, oh, we need to mute walk left and walk right actually. So let's run it again without, yeah, I don't need to look at the, oh, there was a compile issue. State not declared. So the state here is there's no walk left, walk right because we're digging, and then the ground gives, so digging goes down on this cycle, and then the next cycle I say walk right, they say walk left. Of bump left here. So this bump right says go from right to left, but this starts at left already. So is there any bump right that, or maybe there's some bump left that made this left. So here's a bump left where ground is 1 and dig is 0. But it's on the neg edge. Okay, that makes sense because this is like this, and this toggles left to right. Oh, sorry, right to left. This one can toggle left to right if, well, we have a ground again, and we're not digging. But is asserted. But we have here. So what's going on? So here asserted. digging, then this is also ignored. I guess the hard thing is I don't know which bump right made this happen, or bump left made this happen. Is it here? Here, bump left is coincided with positive digging, so 1 and 0. Sorry, 1, yeah, this is gonna be 1, which is 0. This will kill this whole term, so that's not it. The other bump left is here, and there's no digging. The ground is 1, and AH here it is 1. So 1 should just kill this. So I'm not sure why. If AH is 1, then the entire term is 0, so we should have kept going left. So the other thing is like, perhaps this isn't the bump left that caused it. Maybe there's a bump left that's like way farther out. What about when I first start digging? Bump. Like, what if I bump right here? While digging, not when you are told to dig. But I can't really explain the waveform, so... Okay, so this is a spec issue again. So in the previous waveform here, it's not this that caused this kick to the right. It's probably way before when we start digging. But here it says, you know, as with falling, I mean, let's as with falling, being bumped while digging has no effect, and being told to dig. So here it says bump ignored when this is up, but then it actually also includes this dig cycle. See, here it says, as with falling, being bumped while digging has no effect. But like, it doesn't say, you know, being told to dig and while digging, you should ignore bump, right? Which is what this is saying. But this diagram is like not describing that at all. All right, so now there's even more crap. So if A is served for more than 20 cycles, then we turn off all outputs. And splatter is non-output. That's fine. So now it's just adding a counter on top of all this. And yeah, I feel like if this spec was a bit better, these series of 4 questions is actually kind of good for a round of interview. Okay. How many bits do we need? Oh, let's say 5 bits. Any outputs only happen if we're not falling, right? If we're falling, we're kind of preoccupied. Yeah, if we're falling, we're preoccupied. And then so any outputs, namely walking and digging, is 0. Okay. Walking and digging, and except, you know, defalling, obviously, is 0 while we're falling. So this counter can just say, so it basically what I'm trying to say is that the counter is, you know, 0 here, and then the counter is going to be 21 at this cycle because there's a cycle delay for the adder. So if it equals, you know, 21 or more, then you don't have any outputs. So actually though, if it's 21, we just keep it as 21. So if this and not this, so if we're not falling, or if the count, so if we're not falling, or if we are falling and the count is 21, then we just maintain the count. And if we're not falling, we maintain the count. If we're falling and the count isn't 21 yet, we increment it. And then so this will clip it to 21 until reset. And then so we can just assign splatter equals when count is 21, namely this case, but not this case. And then where's all of our outputs? Oh, they only splatter when hitting ground, which complicates things. All 4 outputs become 0 forever. Because this is a forever thing, and actually I want to say if this is 21, so the next count is 21. I can't have count equals 21 because if count is 21 and then we meet ground, then our outputs are shunted 1 cycle too late. So next count is 21. Then splatter is when we hit the ground. So I don't know if this means so there's no examples here, which is again kind of bad. Do we splatter, for example, here? I guess hitting the ground means here or here, I don't know. And if it's here, when ground is 1, do we have it the same cycle? I guess it doesn't matter because if ground is 1, we assert it. It's only the next cycle when A is 0, and when A is 0, then that means other things are eligible. So if we do ground here, that's okay because the A has a 1 cycle delay. So that's okay. And then so if so this just sets it and there's no clear other than reset. So this sets it and this holds the splatter. And then I don't need this anymore. And then I'll just assign my outputs, which is walk left, walk right, and not splatter. and not splatter. And then there is digging. Wondering if this will work, because then ground, but then this has ah still, so this won't be set when this is set. One cycle later, we have splatter set to 1, and digging won't be 1 because we just came out of it, but then we can have this and this and this, but then it would be too late because splatter's set to 1 already. Cool. And then for the stuff, where is that set? Okay, so when ground is set, this will be 0 next cycle anyway, and then every cycle after that, this will make sure that it's 0. $17. Okay. That is, I mean, that's something, yeah, I mean, I guess that's why you name your variable something reasonable. But let's see what mismatches there are. Probably, like, I need to disambiguate this crappy spec again. Oh, one thing I need to do is reset the count when if count is this, then keep this. So if I'm falling and the count isn't this, then add it. If the count is saturated, just keep the count until reset. And if I'm not falling anymore, then just reset to 0. And then if let's see. So if on count is not if on count is that, then we just go to this statement, we saturate it. Otherwise, we're not falling in. It's 1 bit 0. I think this will still have that mismatch because that mismatch is. Oh, okay, I guess not. Line 17. I guess talking about, no, these are just booleans, so, oh, I guess like that. Oh, I guess it's talking about this being a 32-bit one, so I can just, okay, whatever. Okay, cool. So this is a good round of like a series of problems. I think the thing that took me a while on the second and third problem is that they didn't talk about the ground being 1 as being ignoring the bumps, or sorry, ground going to 0 as being ignoring bumps, and then also the other one didn't really talk about like when you start the dig command, it's equivalent to already digging, and then you also ignore the bumps. And then this one, yeah, this one I just forgot to handle the case where you stop falling and you have to reset the count. So yeah, I mean that's it for this round. This is a pretty good example of like building up questions in the 45-minute. I feel like if they gave me like an essay of all these specs from the get-go, that's actually a pretty bad way to do it, because it's like way too much variables to think about. So yeah, anyway, that's it for this one, but this incremental 1 2 3 4 building up to it is pretty good.